So now let's talk a little bit about the OS module. So this is a really cool module within the Python world, and basically what this module allows you to do is it allows you to interact with the underlying operating system your Python script is running on to be able to get all of the functionality and the power out of that operating system. If you want to be able to see if a server is up, you can literally simply run the ping command on the operating system and read the response that comes back. If you want to scan the entire network, you can actually run nmap from the command line, get the entire response back, put it into a variable value within Python, and then parse it as you see fit. Any command line tool that is on your operating system, you now gain access to from Python using the OS module. Now, as with many things in the technology world, right, there's 20 ways to skin a cat. There's always numerous ways to accomplish whatever it is that you're trying to do. And so there is a different module called the Subprocess Module that can be used to replace much of the functionality of the OS module. The Subprocess Module is supposed to be more efficient and supposed to be more secure for many tasks, but as with many things, it's slightly more complicated to get that security and efficiency. And again, in the Silicon Dojo world, our bias is always to try to keep things as simple as possible so that you understand what's going on. And so that's why we focus on the OS module. Now, the warning with the OS module, when we start doing some things with it, is you are going to be able to send commands directly to the operating system. And now the important thing to understand is when you send those commands directly to the operating system, the privilege, right, the security policy that those commands will be running under will be based on your user account or whatever user account you've created to run this particular script. So if the user account is global administrator or it's root, and somebody is able to add some nefarious code into what you're doing, all hell is going to break loose. This is one of the things we talk about with cybersecurity, where you need to create multiple layers of security. So if one layer of security fails, everything doesn't go to hell. That's going to be one of the big ones here. When you create the script and when you run the script, it will run at the privilege level that you're logged in as. And so whatever you're allowed to do on the system, your script is going to be allowed to do on the system. Especially when we start doing things like building small little web applications, that type of deal. If people are able to do an injection attack against the little project that you've created, they can then inject commands that will run at the privilege level that you're logged in at. So if you're logged in as root, or if this script is running at root, that means if somebody is able to do an injection attack, they can basically do whatever the hell they want to your system, and it's going to be a very bad day. So that is one of the big warnings here, so when you use the OS module. Now, one of the big utilities of the OS module is that you can use functions in Python to run different commands against different operating systems. So one of the things that you'll notice once you start getting the Python world and the real world when you're dealing with lots of different types of architecture is that Windows uses different commands than Linux, that may use different commands than Mac. File structure, that type of thing may be different amongst different operating systems. And so one of the problems that you may run into is that if you hard code a command or if you hard code a file path into your script, it may work perfectly on Linux and fail completely on Windows, or vice versa. So one of the cool things is that in the OS module, there are a number of functions for things like make directory, remove directory, creating a file path, that type of deal, where what will happen is Python will detect what operating system it's running on, and then it will simply run the command that's appropriate for that particular operating system. So if you're going to run a script and you need to make a couple of directories, instead of hard coding the command in for what it would be in Linux, you can simply use the make mkdir function within the OS module, and then whether your script is running on Windows or whether it's running on Mac or Linux, it will simply fire off the specific command that's needed. Again, this is going to be also an important thing for file path, right? So whenever you're trying to, let's say, write to a log file or read a log file, read or write or whatever to different files on the system, whether your operating system uses forward slashes or backslashes, right, for file paths is a big deal. If you use the wrong one for the operating system you're in, then the command will fail, your script will fail, everybody will cry. So the nice thing is there's a function within the OS module where you just give it the folders in the file path, and then it will add the particular slashes that are required to get you to where you're going. So that is one of the really big values out of the OS module, and it's one of those things to really be thinking about. Because again, I know you may always use Linux, or you may always use Mac, and so you're like, I don't have to worry about that. I always use this. My company always uses this, and so I'm just going to hard code it. But again, it's not about today, and it's not about tomorrow. It's about 5 years from now, or 10 years from now. Again, legacy code, legacy code. Legacy code started as somebody's little code baby, and then it got really, really ugly. It got really ugly, right? And so one of the things to be thinking about is not today or tomorrow. What happens if 10 years from now, right, this little project that you created is still doing whatever it needs to do, and so they're like, okay, well, we're going to a new infrastructure, let's say a new operating, again, 10 years from now, maybe Tizen, whatever, Samsung, maybe Samsung's operating system has taken over the world. There's Python is on it. They now move the code from, Linux over to the Tizen, or whatever the hell it's called. It goes over there, and now it all breaks because you hard-coded things. Right? The more dynamic you make your code, the better it's going to be. Not just for today, but again, for the poor Slav that's having to deal with your god-awful legacy code 10 years from now. So we are going to go over a number of the functions with the OS module and classes, throughout this series, but here is a list of a lot of the functions that you have. You can get the current working directory that we've used before, things like list directory. So if we just need to list everything that's in our directory, there is an OS function for that, so you don't have to know the particular command for the operating system that you're on. Making directory, removing directory, removing a file. Basically, you've got all of these kinds of things here, and there's a lot of stuff for you to play with. Being able to figure out what operating system you're on, so sending commands directly to the operating system, sending a command to the operating system and receiving a response back, killing a process if some process needs to be killed, system information, CPU count you can get, changing the owner for a path, changing the permissions for a file. There's all kinds of different functions here, and again, the best practice would be to use these functions instead of manually hard coding, again, in case your code ever has to go over to a different operating system. So we're going to have a lot of sessions on the OS module. I love the OS module. You get to do a lot of cool things using the OS module, but be careful. You are literally running commands directly on the operating system with the security privilege that you're logged in as. If you did not hear me before, be careful. As long as you're careful, is a lot of fun.